like them. Okay, chapter 8-5, simplifying rational expressions. Now, when you simplify a rational expression, there are two things we're talking about here. One is, are they attached by multiplication division, or are they attached by addition or subtraction? There's two different methods that go along with each one of those. If they're attached by multiplication division, we already learned that from section 8.4. That was the easier method. Section 8.5 is going to talk about adding and subtracting them. Okay? When you are adding or subtracting two fractions together, you must find a common denominator. When you are solving fractional equations, you will multiply the entire equation by the LCD to get rid of the fraction completely. Do we understand the difference there? Today we're focusing on the blue, not the red. Now you're going to hear me talk about husbands, wives, boyfriends, and girlfriends, men and women's day. Okay, I know that sounds really silly, but I think you'll understand it much easier if I talk about it like that. Sammy, stay with me, bud. If I have 1/2 plus 2/3, if I have 1/2 plus 2/3, 1/2 is boy, 2/3 is the girl. They meet, they like each other. They find that they have things in common. What is in common between 2 and 3? 6. So what you're telling me is their LCD is 6. That's what they have in common. So what we have to do is we have to write their denominators so that they have things in common. So they are recognized as being the couple. Does that make sense? Sure. So what did I multiply 2 by to get 6? What did you do the bottom? You do the top. So 1 times 3 is 3. What did I multiply 3 by to get 6? The bottom? Just do the top. So that gives you 4. So now we can officially see that the boy and the girl have something in common, that they are now a couple. Do we agree? Now the couple are in love, they fall in love, they love each other, they decide to put in one house together. What does that mean? That means I'm writing it as one fraction. His stuff comes in, her stuff comes in, so we have all of their stuff in one house, the living room. His stuff is the 3, her stuff is the 4. Make sense? Then we're going to separate that, make it piles. And whenever we combine all the things together, we're going to have 7/6. Do we understand that, yes or no? Yeah. So we have one house together. Put a boy and a girl in one house together after they fell in love. We all get over it. Makes sense? And that's a really silly example, but do you see it? Okay?
So we're not applying taking in a base fraction.
No. This is just review of what you already know. Like your brain knows this. Now we got to apply it with letters and expressions. For example, this. Okay? Same exact philosophy. Boy meets girl, boy and girl fall in love. But before they can fall in love, they have to first talk and find out that they have things in what? Common. That thing that they're going to find in common is going to be their lovely little LCD. So why? How did we find an LCD here? What did we do? We took the two denominators. 2 times 3, we made it equal to what? 6. Just because it's ugly doesn't mean the procedure changes. Head and body, different head and body. So what we're going to do is we're going to multiply those two different head and bodies together. Do we understand that? So we have a binomial times a binomial. Oh, yeah. Yes? So, they find that they have things in common. That's what they have in common. That's the least common denominator. Do we all agree with me on that? When in doubt, take the denominators, multiply them together. But my question is how am I going from b plus 2 on the first fraction's denominator down to the new common denominator, b plus 2 times b plus 3? What am I multiplying by? I am multiplying by b plus 3. What you do to the bottom, you must do to the top. Well, what did I multiply b plus 3 by to get the b plus 2 times b plus 3? What did you do to the bottom?
You gotta do the top.
You must do to the top. Do we all see that? Well, now guess what? They have loved each other so much that now they decided to get married, right? So when you marry two fractions that are attached by addition or subtraction, you are simply writing them as one long, ugly fraction. They share one denominator because that denominator is the same because if you're married, you don't live in two separate houses unless you live across the state from each other. So we're going to go ahead and put their junk in the same house together. Do we all understand that? Yes or no? Sure. Does that make sense? Can you see it? It's stuff for stuff. Nate? Okay, well, now we have to organize it. Whenever I say organize, what does that mean in this example? Simplify. It's already in its factored form, so what I need to do is distribute and FOIL, right? So I'm going to distribute the b to give me b squared plus 3b, and then I'm going to distribute the negative. So that's going to give me plus a negative b minus a1, putting parentheses around that and dropping down the b plus the 2. Why am I doing that? Because that negative is going to go to every single term in there. You need to ask a question.
Okay, right there. You got B and B plus 3 and then B and then negative.
Huh?
How do you know there's a 3 there and a 3 there?
I put the b plus 3 on the left and the b plus 2 on the right.
Yeah.
Because you add to them what they're missing. In the original problem, I have a b plus 2 already. What I needed was a b plus 3 tacked on.
Okay.
Which is the bottom, half to the top. Okay. So now I come all the way back down here. What am I going to do with 2 parentheses now? Well, what am I doing? I'm going to FOIL. So I'm going to recopy this junk on the left, and I'm going to make that negative b squared minus 2b minus b minus 2 all over that denominator. Now what do you think you want to do still? There was a lot of junk at his house and a lot of junk at her house, right? So we got to keep sifting through it. So what do I do here? Combine like terms. I need to figure out what I want to keep and what needs to go to the yard sale. So the b's cancel, b squareds cancel out. 3 bananas minus 2 bananas gives you 1 banana. A banana minus a banana gives me no bananas. And what am I left with on top? -2. I'm left with a whole -2 over b plus 2 times b plus 3. Can I do anything with that? I can't cancel anything out, so I'm done.
Good.
Do we get that? Good. So, let's do it again.
Wow. That's a lot of work. Oh. Oh, that's it.
Why would I want to put this into 2 binomials? Because the denominator is not factored, is it? I don't know what they share and have in common if I don't factor each one of them into 2 binomials. Does that make sense? It's kind of like saying you have so much in common by just looking at them across from the room. You haven't even said a word to each other yet, right? How do mathematical expressions talk? They talk in 2 binomials. Isn't that great? You didn't know mathematical terms, did you? X minus 3 all over. What does x squared minus x minus 6 turn into? Tell me what to write. Don't tell me x and x. What do you say? How do I put that in 2 binomials? Oh.
Okay.
I don't know.
3x. Parentheses x minus 3, and then parentheses and another one, which plus x plus 2.
You are correct. Can I go ahead and make this plus and go ahead and distribute that? Could I do that now? Sure I could. I can make this a plus and make that a negative x minus 3 on top. Can I factor that into 2 binomials? Yeah, what would it be? X minus 3, x minus 2. Okay, now that we've factored this, now we need to find out what's in common. Well, a least common multiple, or a least common denominator as we know it, is going to be, what do they have in common? This has an x minus 3. Does this have an x minus 3?
Yes.
How many does each one of them have? This one has 1, this one has 1, so I'm going to have an x minus 3. This has an x plus 2. Does this one have an x plus 2?
No.
No. Does it need to have an x plus 2 because this one has one? Yes. The whole point is to say that you're compatible. And the only way you can be compatible is that you have exactly the same denominators. So this one has an x minus 2, but that one does not. Do I need both of them to have an x minus 2? Yes, that's the whole goal.
Where did you get x minus 3 and x plus 2?
I factored the x squared minus x minus 6 into two binomials. Split up x and x. I need to have a negative 6, so I'm going to have negative 3 times positive 2 is a negative 6. Inner's negative 3, outer's positive 2 to give me the negative 1x. Okay? Now that we've factored this completely, I need this fraction to have that least common denominator. I need this fraction to turn into that denominator. So what we're going to do is we're going to write it down like that. We're going to have x plus x minus 3, x plus 2 times x minus 2, plus x minus 3, x plus 2, x minus 2. That denominator is the terms and condition of their relationship. They're saying this is what we have in common, this is what we're basing our relationship on. Does that make sense? Now, in order for that to take place, what is missing up here in this step, the x minus 3x plus 2, that I have now turned into the x minus 3x plus 2x minus 2? What is missing?
The first one is the negative for the x minus 2.
So what you do to the bottom, you must do to the top. So what we're going to do is we're going to tack on the x minus 2 because we tacked on the x minus 2 on the bottom of it, right? So we want to make sure I tack it on to the top to make it equivalent. Okay? Now what am I going to do on the bottom here? I have x minus 3, x minus 2. What did I tack on? The x plus 2. So again, I'm going to have the negative x minus 3, which was the original, and then I'm going to tack on the x plus the 2. Do we see that? Okay, perfect. So now I have two fractions that are now in love, and they have the same denominator, but now we're going to move in the same house. What does that mean? If I'm moving in the same house, how many denominators do I need when I move in the same house? I need one denominator. So I'm going to have the x minus the 3 times the x plus the 2 times the x minus the 2. One denominator, because two people are going in one house, right? It's one fraction. And I'm just going to tack on that numerator from each one. There's the guy's stuff, and here's the woman's stuff. All that stuff is sitting in the linear. Now what are you going to do? You're going to unload those boxes. What are you going to do? Combine like terms, organize them, right? So how do I go about doing that? You can't cancel until I get rid of parentheses, because the parentheses represent the boxes, right? Can you visualize the boxes? Those boxes are going to be your parentheses. So I'm going to FOIL that. X times x is x squared minus 2x minus 3x plus 6 minus x squared minus 2x minus 3x minus 6. All over this jump, which is our house. Okay? Now, I want you to visualize those parentheses as being your boxes. The first thing you want to do whenever you have a bunch of boxes in your living room is you unload them, right? You get rid of the boxes. Once you get rid of the boxes, then you can start doing what? Organizing, right? And piles. So that's the same concept we got going on here. So from left to right, what am I going to do? X squared and negative x squared cancel out. Negative 2x and negative 3x give me negative 5x. Negative 2x and negative 3x give me negative 5x over here. So how many total x do I have?
Negative 10.
I have negative 10x. What happens to 6 and minus 6? They cancel out, and I'm all over this lovely little denominator. Can I cancel anything out? No, this thing is done. Do we understand that? This is a long, involved process. This is not easy. Okay? I want to make that abundantly clear. This is not easy. What I'm going to do is I'm going to start you out with your homework. We're going to start it out together here. I'm so glad. Homework is so refreshing.
No, it's not.
It just like makes everybody's world go round, doesn't it?
Yeah. I love having it every day of the week.
Makes me feel my world is on fire.
I am so glad because I would hate it if your world was on fire. That meant you would just go off with your life with blunders on. It was boring. At least I give you something to think about. Have a little bit of fun. But make your night boring.
Yeah.
Okay. Problem 1 through 4. You guys have. He has 2.
Yeah, okay.
I lied.
Wow, you're lying much today.
Please forgive me. I thought. Okay. Number 1 through 4, it says find the least common multiple of each pair of polynomials. When we're talking about multiple, are we all listening? You are taking the value and you're doing your multiplication tables of it. For example, number 1, 3 and 6. I'm doing my multiplication tables of 3 and I'm doing my multiplication tables of 6. What's the first thing that they have in common? 6 is the first thing they have in common. Your least common multiple cannot be smaller than the largest value. Because it can't give smaller than what it is. 6 cannot be smaller than 6. Do we understand that? Its first multiplication table is 6. Do we get that?
Yes.
So, your least common multiple here between 3 and 6 is going to be a 6. Now, what about x and x? Well, smallest that x can give is x. The smallest x to the first can give is x to the first. Do we understand that?
Yeah.
So what's in common there? An x. Look at this binomial, x plus 2. Do they both have an x plus 2 in them? No. Do they need to both have x plus 2s?
Yeah.
Yes. Go over here. This has 2x minus 3. Do they both have a 2x plus minus 3?
No.
Do they both need to have that? Yes. So your LCD is 6x times x plus 2 times 2x minus 3. Let's do it again. Number 3.
That's all you have to do.
Yep. Number 3. What do I do with that?
You have to put binomials
Why do I have to put into 2 binomials?
together.
Because I don't know what 4x squared plus 12x plus 9 is compared to 4x minus 9 unless I put them into binomials. So I need to factor this. That's going to be 2x and 2x. That's going to be 3 and 3 plus and plus. So how many 2x plus 3's do I have here? I have 2. So if I'm doing my multiplication tables, can I give any less than 2x plus 3 squared? Do we all understand that? Okay. Come over here to the other one. How do I factor 4x squared minus 9? Well, that's 2x and 2x, 3 and 3, and I need a negative, so that means plus minus. Okay, now I need my least common multiple. Do they both have 2x plus 3 in them?
Yes.
How many does the first one have?
2.
How many does the second one have?
1.
What did I say? It cannot be smaller than the largest number you have, right?
Yeah.
So I have to have how many 2x plus 3's?
3.
I have to have 2. And why? Because 2x plus 3, there's already 1 over here. So a multiple of that would be doing another one. Okay? So I have to have 2 of the 2x plus 3's there. Now, do they both have a 2x minus 3? No. So what do I have to do?
Add it.
It has to be tacked on there. That is my least common multiple. Do we understand that, yes or no?
Yes.
Okay, moving right along. Number 5. I give you x squared over 5 plus x squared over 5. The directions say simplify each sum are different. State any restrictions on the variable. What in the world are they talking about? State any restrictions on the variable. I don't understand.
Domain restriction.
I'm looking for my domain restrictions. When do I have a domain restriction?
We have
When I have a letter in the denominator. We all understand that.
yeah.
Okay, so first things first. Do they like each other?
Yes.
Yeah.
How do I know that they like each other? They have the same denominator, which means do I need to get a common denominator? No. They are ready to move in one house together. Does that make sense? So how do I write this?
X
X squared plus x squared over 5. How many of you wanted to write 10?
Me.
I know. Yeah.
Don't do that. That's why I'm talking about it. Don't do that because all you're saying is I'm putting them both in the same house, which means I keep the denominator. Do we all understand that? Now, what's x squared plus x squared? 2x squared. Come on, apples with apples. 1x squared plus 1x squared is 2x squared, right? We're not multiplying, we're adding. I cannot do anything else with that. So my next question is, do I have any domain restrictions? There's not a variable in the denominator, so it doesn't matter what x is here. Are we good?
Yes.
Number 9.
Let me find it.
Number 9. Now, let's talk about this again. First, we want to find what's going to be my LCD. Now, what did I talk about previously whenever we were doing our least common multiples? It cannot be smaller than, what's the largest number in the denominator? 10. So, what's my first multiplication table of 10? Does 5 go into 10? So 10 works, doesn't it? How many x squareds are in the first denominator?
2, 1.
2 x's are in the first denominator, right? Go in the second denominator. How many x's are over there? 1. So how many total x's do I have to have?
2.
I have to have 2. So that's going to give me x squared. How many y's do I have in my first denominator?
1.
How many do I have in my second?
2.
So what's my least common denominator then?
2.
Y squared. Do we all see that, yes or no?
Yes.
So I need to make it so that these two kiddos like each other. Well, the only way we can prove that they like each other is by having each one of them have the same denominator. So what did I do to 5 to get 10? I multiplied it by 2, and then what else? What did I do to x squared to get x squared? Nothing. What did I do to y to get y squared? I multiplied by y. So what I'm actually multiplying by is 2y. Do we understand that?
Yeah.
Go to the second one. The 5 I bring down. What did I multiply 10 by to get 10?
6.
I don't want to change it so it's the same. What did I multiply x by to get x squared? And what do I multiply y squared to get y squared?
Nothing.
Nothing. Okay, so now these two fractions like each other.
Yeah.
So now what are we going to do? Go into one house, which means do I change the denominator?
No.
No. So I'm going to have 10x squared y squared in my denominator. Now how do I write that in my numerator? What do I do?
12y plus 5x.
12y plus 5x. Can I cancel anything out there? No, there's nothing in common there, so this is going to be my answer. But the next thing I need to do is consider, do I have any restrictions?
Yeah.
Well, my denominator cannot be 0, correct? So how are my x and y attached here? So what can x not be?
0.
X can't be 0 because if it is, then 0 times anything is 0. What can y not be?
0.
Y cannot be 0 either because if I have y times being 0, 0 times anything will be 0. So there's my two restrictions. Do we understand that, yes or no? We good? Let's do 11. 4 over x squared minus 25 plus 6 over x squared plus 6x plus 5. What do I do first?
Run your LCD.
I need to factor that to two binomials. So that's going to be 4 over x plus 5, x minus 5, plus x plus 1, x plus 5. Do we all agree? Now, I need my least common denominator. Do they both have an x plus 5 in them? Yep, so I'm going to have an x plus 5. Do they both have an x minus 5? Nope, but they need to. Do they both have an x plus 1? Nope, but they need to. And we already know we have an x plus 5. Do we all see that, yes or no? So each one of these fractions needs to have that ugly denominator. 4 by to get that new denominator. What was missing up here? The x plus 1 is what I'm going to tack on. Do we understand that? Yep. I'm going to bring down my numerator here, and what is missing from that one?
X minus 5.
The x minus 5. So I'm going to tack on the x minus 5. Do we understand that?
Okay, so pretty much put the one on the other one and put on both.
Yes, sir. Yep. So now, we like each other. Move into one house. So what do I do with my denominators? 4 times x plus 1 plus 6 times x minus 5 all over the denominator x plus 5, x minus 5, x plus 1. Now what do the parentheses represent? Boxes. What do we like to do with boxes? Unpack this. What do I do with these parentheses? We get rid of our boxes by unpacking them, so I need to distribute here. So 4x plus 4 plus 6x minus 30, all over this jump. What's 4x plus 6x? $10x. 4 minus 30 gives me 26, all over this jump. Now, if I pull out a GCF of a 2, is that going to matter? No. So this is my answer. Now, do I have any domain restrictions? Very good. You have evens to do. Now, I want to draw your attention to the back here. 14, 16, and 18. You have a fraction divided by a fraction, right? I want you to write them vertically, or change them from writing vertically to horizontally. So 14 is equal to 1 plus 2 over x, parenthesis, divided by, parenthesis, 4 minus 4 over x over 6. If you write them like that, you have a whole different problem. Do you understand that? Have a great day, folks!